All right, so today we are going to apply radicals in geometry. So our learning targets: to write an equation for finding the side length or radius of a rectangle, a right triangle, square, or circle. And then we're going to solve this equation for the unknown. So this is a very familiar equation for you if you have a right triangle. The sum of the squares of the lengths of the two legs is equal to the square of the length of the hypotenuse. So basically a squared plus b squared equals c squared, where a and b are the two legs. They're the ones that make up that nice little 90-degree angle over here. So that's your a and your b. And then your hypotenuse is always straight across from the 90-degree angle. So we are going to find the length of the hypotenuse. So set it up. Use your a squared plus b squared equals c squared. Which one's a, which one's b, and which one's c? Well, a and b, it doesn't matter which way you do that, but they're the ones that make up the 90-degree angle. So 3 and 4 make up the 90-degree angle. And c is the hypotenuse and it's straight across from a 90-degree angle. So plug your values into the Pythagorean theorem there. So 3 squared there is 9. So we get 9 plus 16 equals x squared. 9 plus 16 there is 25. To get rid of the to get rid of that squared around the x there, we're going to have to take the square root of both sides. We don't have to worry about the plus or minus because we can't have a negative for a side length of a for a triangle there. So we end up getting x equals 5. So 5 is the length of the hypotenuse. Find the missing side of the triangle. So again, we've got a right triangle. We've got two sides given. What are we going to use? Yes, the Pythagorean theorem. Identify sides A and B. They make up the 90-degree angle. So those are my A's and my B's. And then my C is right across from the 90-degree angle. Plug them into the formula. So now you can just do your computations on that. So now 5 squared is 25, 13 squared is 169. We have to get rid of the 25 because we want to get x squared by itself. And now we have to get rid of the squared. So to undo the squared, you take the square root of both sides. And we end up getting x equals 12. We don't have any units on this. It's just a 12. It didn't tell us. You weren't told in the problem there what kind of units it was. It wasn't like there was 5 centimeters or anything, so we don't have to label that answer. All right, example 3 here. Find the length of a longer leg of a right triangle if the length of the shorter leg is 9 centimeters and the length of the hypotenuse is 41 centimeters. So a problem like this, I always like to draw out a picture. So we're talking about a right triangle, so I'm going to draw out a right triangle. And it's just some generic one. It's not going to be exactly the way it's supposed to be here. So the length of the longer leg, we're supposed to find the length of the longer leg. So this looks like a longer leg to me. The shorter leg there is 9 centimeters. The hypotenuse is straight across from a 90-degree angle. And they told us that's 41 centimeters. So again, it's a right triangle. We have two sides given. We have one missing side, so we can use the Pythagorean theorem. Go ahead and substitute your values in there after you identify A, B, and C of your triangle. Now do your computation. Go ahead and find out if you know what 9 squared there is 81, and 41 squared is 1,681. Now you have to get the x squared by itself, so you need to get rid of the 81. It's adding 81, so we have to do the inverse of that, which is subtract 81. So now all we have to do is take the square root there of 1,600. So when you take the square root of both sides there, we get x equals 40, and then since the other sides there had a label there of centimeters, we're going to have to label our answer here as centimeters. All right, example 4. The area of a square is 24 square centimeters. Express the length of a side of a square in simplest radical form. So again, it's geometry. I like to draw a picture when I have a geometry problem. A square, what do you know about the side lengths of a square? They're all the same. So each of the lengths of this square in here are x. How do you find the area of a square? Base times height, right? Or length times width. So I'm going to say base times height there. So we have an area there of 24 square centimeters. And both the base and the height, or the length and the width, are exactly the same thing in this square here, and I called those x. So I have to go ahead and multiply x times x. So when we multiply x times x there, we get x squared. We have to solve for x, so we have to take the square root of both sides. The square root of 24, it says to simplify it down to simplest radical form. So this is going to be the even square root, so we're going to have to break down the square root of 24. What goes into 24? So you got 1 and 24, you've got 2 and 12, you got 3 and 8, or 4 and 6. So if you want to break it down and use your prime factorization table, you could, or tree there, you could do that. Otherwise, I'm going to choose 4 and 6 there because I can find the square root of 4. The square root of 4 there's 2. And I'm left there with the square root of 6. So 2 square root of 6. And the area there was in square centimeters, so each one of those sides is in centimeters. So I'm going to label it 2 square root of 6 centimeters. A ramp was constructed to load a truck. The ramp is 9 feet long, and the horizontal distance from the bottom of the ramp to the truck is 7 feet. What is the vertical height of the ramp? So here's the bottom of the ramp here, and the truck must be parked over here or something. So, and it's probably right dead against that ramp there because I have the truck backwards. So there's my little truck. So this is 7 feet. The ramp is 9 feet. And we want to know what the vertical height of the ramp there is. So we don't have this over here. So again, a nice 9-degree angle there. Straight across from that is my hypotenuse. So this is C. The other two are my A and my B. So let's use the Pythagorean theorem on this one as well. Now we have to solve for x squared, so you need to subtract 49 from both sides. Go ahead and take the square root of both sides. Break down 32. So again, you choose what method you like to do. So I'm going to go ahead and use a prime factorization tree because I haven't used one in a little while. So I'm thinking what times what gives me 32, so maybe 4 times 8. But 4 can be broken down as 2 times 2, and 8 can be broken down as 4 times 2. And then that 4 can still be broken down as 2 times 2. And so now I'm looking for pairs. So I'm stopping there because those are all prime numbers now. So I'm looking for pairs. So I've got a pair of 2s, so a 2 comes out. I've got another pair of 2s, so another 2 comes out. And then that single 2 that's sitting over there goes underneath the square root. So simplify your numbers there on the outside. So 2 times 2, there's 4. And so we get 4 square root of 2. And this whole thing is in terms of feet. So we're labeling our answer there. All right, there is a 13-foot ladder leaning against the side of a building. The ladder reaches up the building 12 feet. How far is the bottom of the ladder to the bottom of the building? So there we have our nice right triangle. So remember, straight across from a 90-degree angle, there's your hypotenuse, so that's C. So I'm using my Pythagorean theorem again. I've got my A and my B and my C, so let's set it up. So 12 squared there is 144. 13 squared is 169. We have to get the x squared by itself, so we're going to have to subtract 144 from both sides. We have to use the inverse operation from addition, which is subtraction. Now we have x squared equals 25, so to get rid of the squared, we have to undo it by using the square root. So we end up getting x equals 5. And so now we're going to label our answer there in terms of feet. All right, a square. So I have another picture I'm going to draw out of square. The diagonal, that goes from corner to corner. So I'm going to draw my diagonal in there. It says find the diagonal of a square, so we don't have this diagonal, and whose sides are 5 centimeters long. So the sides of the square here are 5 centimeters and 5 centimeters. So looking at this nice triangle, this right triangle that's been formed in here, we can go ahead and set up our Pythagorean theorem again. Straight across from a 90-degree angle, there is C. The other two sides are A and B. So 5 squared there is 25. So 25 plus 25 is 50. You have to undo that squared, so we have to take the square root of both sides. Square root of 50. So you can either break it down. If I break down 50, maybe I'll do 5 and 10. Can't break down 5 any farther because it's prime. Break down 10, 2 and 5. Looking for a pair. I've got a pair of 5s. So the 5 comes out. And then there's a 2 left over, so that goes underneath the square root. So we get 5 square root of 2, and since the sides there are in terms of centimeters, so is the diagonal. Don't forget to label your answers. All right, another square. What is the length of a side of a square if the length of the diagonal is a square root of 72 inches? All right, this time they gave us the diagonal. And we don't have the lengths of the side of the square. Here's my 9-degree angle. Straight across from that is C. So here's my A and here's my B. So set up your Pythagorean theorem. Since you have 2 x's in there, we're going to be able to solve this. So A there is x, B is x, and C is a square root of 72. So this is like a 1x squared plus a 1x squared gives me a 2x squared. If you square a square root, they just cancel each other out. So that square root of 72 squared, that square root and that squared cancel each other out, and we just get a 72. On the left-hand side, we cannot take a square root of both sides there until we get rid of that 2. That x squared has to be by itself before we can do that. So let's get rid of that 2. So the 2 is connected to the x squared there by multiplication. So we have to divide both sides there by 2. So we end up getting x squared equals 36. Now we can go ahead and take the square root of both sides. And we end up getting x equals 6. Now label that inches. So 6 inches is each side of the square. All right, so we have the area of a circular sandbox is 20 x is 6, y to the 12th times pi square meters. Express the radius of a sandbox in simplest radical form. So looking at one like this one here, let's go ahead and let's think about how do you find the area of a circle. Well, area of a circle there, area is equal to pi r squared. All right, so they told us the area, so let's just plug that in there. So 20 x to the 6th, y to the 12th times pi equals pi r squared. So they're asking us here to find the radius, which is halfway across that circle. So it's from the center of the circle to a point on the circle. So that would be the radius there. So we're supposed to solve this nice equation we have here for r. So what you want to do here is over here you want to get this r squared over here on the right hand side there by itself. To be able to do that, we're going to have to divide both sides there by pi. So notice what happens there, all those pi's there cancel out. So now we have 20 x to the 6th, y to the 12th equals r squared. So to get r all by itself there, we're going to have to get rid of that squared. So we're going to have to take the square root of both sides. And so we're going to have to find the square root of 20. So either break it down and use your prime factorization tree like we've been doing. If you want, you could do 4 and 5. Break down 4. There's a pair of 2s, so a 2 comes out in front. You've got a 5 left underneath. Got to put the 5 back underneath the square root. What's the square root of x to the 6? Remember, you can put that little 2 out there. Since they're even powers, I can just do 6 divided by 2, which is 3, so I get x to the 3rd. Y to the 12th, there's a little 2 out there on the outside, so just do 12 divided by 2, which is 6, so you get y to the 6th. All right, so now I'm just going to rewrite it so it's in a nice order. So r there equals 2x to the 3rd, y to the 6th. And the square root of 5 there goes last. And then look there to see if we have any units that we need to put it in there. Area was square meters, so radius there is just, it's just a linear unit there, so it's just meters. So I can write an equation for finding the side length or radius of a rectangle, right triangle, square, or circle. I can solve an equation for finding the side length or radius of a rectangle, right triangle, square, or circle. All right, so there we have it.